Welcome. My name is Jason Switzer. I'm the Executive Director of the Alberta Clean Technology Industry Alliance. And we have a fantastic session this morning or this evening, depending on where you're joining us. This industry session seeks to enable insight and dialogue between the developers of solutions in hydrogen, CCUS, and fuel cells with global corporate partners and customers, and to offer insights from the experience of those global partners. I'll introduce our esteemed panelists in a moment, but first, let me remind you to make use of Slido for questions, which I'll moderate. If you have a cell phone or otherwise on the internet, please log into slido.com. The website and code are going to be dropped in the chat momentarily, and I believe we are industry matchmaking number 1. That's industry matchmaking number 1. Both the code, the website, and that will be validated in the chat momentarily. Please post your questions there, and participants will then upvote the questions, and of course our panelists will be asked to respond to the ones that get upvoted. And I have the happy task of just conveying those questions to the panel. Okay, over to the substance. We have two very experienced people in the fuel cells and CCS technology space. Two very experienced people who've worked to actually deploy those in the field for widespread use. And based on that experience, colleagues, we look to you to share your insights for emerging ventures in terms of commercializing those technologies and in particular advancing projects that use them. What are the opportunities that are of greatest interest to global corporations or global customers, the people that you work with in your roles? Our panelists, first up, Professor Dr. Christian Mohrdieck is Managing Director of fuel cell manufacturer CellCentric and has been CEO of Mercedes-Benz Fuel Cell since 2015. In June 2020, he assumed additional responsibility as Managing Director at Daimler Truck Fuel Cell. In his spare time, of course, Dr. Mohrdieck also teaches at the University of Ulm and the Technical University of Vienna. Our other panelist, as Vice President, Strategy and Stakeholder Relations, Beth Valiaho represents the International CCS Knowledge Center on the global stage to share that hard-won knowledge from real experience in deployment to unlock investment in CCS and to support achievement of the Paris Agreement. Beth combines previous roles as legal counsel for Crown Utility with regulatory experience within the government of Saskatchewan and with deep policy analysis expertise as part of the National Roundtable on the Environment and the Economy. And similar to Dr. Mohrdieck, Ms. Valiaho has also taught. Both panelists have a commitment to sharing what they've learned with the next cohort of changemakers, which really brings us to our discussion today. So first, let me welcome Christian on stage. So Christian, if you wouldn't mind turning on your camera. Why don't you share with us your presentation, and I will step out of your way and allow you to do so, sir.
Good morning. Yeah, good morning, everybody. I'm very happy that I can share some insights with you how we do see clean technologies, especially fuel cells, and how SMEs could contribute to this technology in principle. So thank you very much again to the organizers to invite me to talk about CETA opportunities and clean technologies, especially focused on fuel cells. So let me start with some general remarks. I think hopefully we all agree that climate change is not a myth anymore. CO2 emissions are the main driver for climate change, and CO2 emissions by mankind are increasing as we speak. The increase actually started several hundred years ago. And trucks are contributing to these emissions quite a bit. So about 5% of the global anthropogenic CO2 emissions are from trucks. Trucks which do 15 trillion kilometers per year and emit 2 billion tons of CO2 every year. So I think it's of paramount interest of all of us to reduce these emissions coming from trucks. So the European Union has issued very strict regulations for the CO2 reduction in heavy duty coming from heavy duty vehicles. So by 2025, they have to be reduced by 15%, and in 2030 by 30%, even in comparison to the emission level in 2019. And the European Union is even discussing at this point in time whether the emission limits should be increased in 2030. And if you don't comply, you have to pay huge fines. So for example, in 2030, per gram per 1,000 kilometers, there is a penalty of 6,800 euros for the exceedance of the CO2 limit. So the only way to comply is to have a certain number of zero emission vehicles, because you cannot achieve these very strict goals by just improving internal combustion technologies. So there's only two ways to have zero emission vehicles. It's either batteries or hydrogen fuel cells. And our strategy is that depending on the specific vehicle, depending on the application of the vehicle, you will choose either one. So battery technology is very good for smaller vehicles with limited range or planned routes, whereas hydrogen fuel cells can be applied to long-haul heavy-duty or Class 8 trucks very easily. And this is a segment which contributes significantly to the CO2 emissions in the heavy-duty area. So for us, hydrogen and fuel cells are essential for our future success. Daimler has a long history with fuel cells. Actually, we presented the first fuel cell vehicle, and this was a commercial vehicle in 1994. You can see the vehicle on the left-hand side of this slide. And over the past years, we further developed the technology. We solved all the functional issues. And at this point in time today, we are on the verge of transferring this technology to heavy-duty vehicles. In the past, we've made a number of passenger car vehicles, and Canada has played a major role in this technology development because, as I will explain, we do have a site in Burnaby, British Columbia, where part of our stack development and also stack manufacturing takes place, which is and was always essential for the success of our fuel cell development. So in order to speed up, in order to accelerate this development, Daimler and Volvo teamed up last year in order to form Cellcentric, which was put in operation on March 1st, so this month, because the two companies do have the same ambition. They want to comply, they want to implement the Paris Agreement from 2015 and want to be carbon neutral in the triad markets, which is European Union and should read North America, not just USA, and Japan by 2039 or 2040. So this seems to be far out in the future, but if you take into account that the life of a heavy-duty truck is at least 10 years, you should start early to have to achieve this goal in 2040. We need to start almost now in order to convert the whole fleet into zero-emission vehicles. As I already mentioned, we have a very strong site in Vancouver or close to Vancouver in Burnaby. Actually, more than 400 people are working on fuel cell development in our Cellcentric organization. Some of them in Stuttgart und Turkheim, where our production site for the fuel cell system is. Our headquarters is close to Stuttgart in a small city called Nabern, where all the fuel cell system and stack development is taking place, where the major testing facilities are located. And from this side, we also do all the public relation topics to the outside hydrogen world. Burnaby is our third location with more than 50 people on site doing serious manufacturing process development, especially for stack, parts of the fuel cell stack development, especially the membrane electrolyte frame assembly, as we call it, and the low volume stack production for the upcoming truck fleets and stationary applications, which I will explain in a minute. So this is how our system looks like. So many people would say it looks like an internal combustion engine with cables, with pipes, with a rigid housing in the middle. And this is actually true. It looks like an internal combustion. It's mounted to the vehicle like an internal combustion engine. And the assembly process resembles in many regards to the assembly process of an internal combustion engine. However, it's an electric engine, if I may say so. So the fuel cell provides up to more than 800 volts of electric voltage to run an electric motor in the vehicle. It has to have high lifetime and durability. It has to comply with the weight restrictions on such vehicles. Efficiency is very important for fuel economy, and it has to have the appropriate robustness. So let me have a look a little bit more in detail into this engine. So there is a fuel cell stack consisting of different cells. There is a housing, an enclosure. There's a humidifier with humidifier membranes, a power distribution unit, so a power electronics part, DC-DC converters, and an electric turbocharger. And for all these different components, we need to work with partners, with suppliers. All these components are not completely made in-house, but for all components, we are working with partners worldwide, and we would be very happy to have more partners in Canada. So this system is actually highly integrated. It is set up for production design. It has a very high degree of serviceability right from the beginning. And essentially, we put into this engine all our 25 years of fuel cell experience. So what is our expectation to potential partners wherever they come from? So for sure, we have to have a look at the cost. Cost is one of the major challenges in fuel cell technology. One lever to reduce cost is increase volume. But in order to do this, we need a strict price development. We need cost transparency from our partners, the willingness to talk about the cost, the willingness to talk about price also. We do have some legal requirements. We do have special terms and conditions, like probably all automotive companies, which need to be fulfilled in order to have our product liability fulfilled. We need reliable and flexible delivery in regard to deadlines and quantities. For sure, not only the trucks with the fuel cells should be sustainable, but we are also looking at a sustainable procurement chain. So in Germany, and most likely later also in Europe, there will be a regulation about sustainable procurement chains all over our product landscape. We are looking for innovative manufacturing processes. Fuel cell technology is new to the automotive business. It's not mechanical engineering. It's more like process engineering and chemical engineering. So this is a new field where we need innovative technologies in order to increase the volume. Service is essential. So communication and response time to inquiries are really of the utmost importance. And last but not least, quality is a major ingredient, as you might know from both the brand of Mercedes-Benz and also Volvo. They have very high quality standards. So we are requiring from our partners they should be certified according to IATF 16949, I'm sorry, ISO 14001, which is an environmental audit, and if possible, also complying with the VDA regulations. So in order then to commercialize fuel cells, what is missing? I think commitments and investments are done as we speak. Daimler and Volvo are committed to go to sufficient economies of scale in order to reduce the cost. We also teamed up with MTU, Rolls-Royce Power Systems, and to do stationary applications of fuel cells. But there's one third thing where we need to work together with more companies, and that's what I would call credibility, voice of the industry. We need to shape a hydrogen and fuel cell ecosystem, and this is not just done by automotive OEMs. We need a broader partnership with suppliers, whether they are small or big companies, doesn't matter as long as they comply with our demands. We would like to welcome any company helping to commercialize this technology. So let me conclude. We have a motto, which is we power sustainable life. We are self-centric, and we would like to make fuel cell a viable technology and be very happy to have Canadian companies join us on this trip. And our Canadian colleagues in Burnaby, they are welcome to be an interface to any Canadian company which is interested in working with us. So thank you very much. This is just a short introduction into our technology and our, I would say, landscape, how we would like to form the commercial viability of fuel cells together with other partners, and hopefully many from Canada. Thank you.
Christian, thank you. That was a super overview, and I trust that will give our audience lots to consider. I'll ask the organizers to again post the link to the Slido in the chat. I see some questions coming in, but maybe just to warm you up, you mentioned three factors around commitment, scale, and really I would interpret it as a growth of a supply chain and ecosystem around the technology. But you know, one of the big challenges arguably has been getting the infrastructure built. I wonder if you can comment on that. Where do things stand in terms of building the infrastructure for supplying hydrogen?
That's a very important point. Thank you, Jason. Actually, we are also talking to infrastructure companies like the big oil companies, the gas companies, and also governmental authorities in order to set up a corresponding infrastructure which has to be developed in parallel to the vehicle deployment. So if we would put, I don't know, 10,000 trucks on the road today, nobody would probably buy them because nobody knows where to refuel. So this is, I think, really a giant effort which has to be undertaken in parallel.
Thank you. Now let me turn to a few of the questions in the Slido. Is electrification a viable path? You speak to fuel cells, but what are some of the most promising startup technologies that you see both on electrification as well as in fuel cells?
So in electrification, if you mean battery electrification or electrification by batteries, with this term, I think we need further reduction in battery cost. We also need increase in energy and power density on the battery side. And on the fuel cell side, it's very similar. We need more affordable components, which can be done by both increasing volume, but there's also technology efforts needed in order to make components smaller, for example, to make them more powerful, to drive up efficiency further. So there's technology development needed, but also production volume increase needed. And then depending on the application, we think there is not one silver bullet which can solve all the electrification or alternative drivetrain challenges, but we need a variety of drivetrain technologies ranging from internal combustion engines, hybrid technology, battery technology, and fuel cell technology to build the best solution for our customers in every case. And this also, I think, shows what the financial challenge is. So instead of developing one technology, internal combustion engines, we are now faced with a situation that we need to develop a number of technologies in parallel. And that's why so many partnerships are set up, like the one we did or we do with Volvo.
Thank you. And one partnership that I'm particularly familiar with, because I was an early investor in Ballard back in the heady days of the early 90s, was the partnership between your company and Ballard to try and commercialize fuel cells in vehicles at that time. How do we know that this time is different than that time? What's going to help us ensure that we don't see another kind of boom of optimism followed by a kind of wake of disappointment?
Yeah, first of all, let me say that in the 1990s, I think together with Ballard, I can state we laid the foundation for this technology. And both companies, Ballard and we, are very successful, or we have been always very successful with that. I think the seriousness with the technology now is very different than it used to be 20 years ago. Regulations are very strict. I think there's no way out by paying fines for us. So the only way to comply is really implement the technology. And at the same time, infrastructure now is at a level where it can be initiated in order to have enough refueling possibilities for our customers. So that's a big change in regulations, big change in infrastructure. And I have to admit also, we needed some time to develop the technology. When we started in the 1990s, nobody had an idea to start a fuel cell at temperatures below freezing, which is quite important, especially for a country like Canada. Today, we don't have any functional issues with the fuel cell anymore, but this took quite some time to get there.
Thank you for that. More questions in the Slido. Do you see CellCentric expanding its value chain to include system integration for other applications outside of automotive and its associated infrastructure? So I guess, do you see this going into other sectors?
Yes, I do. And I briefly mentioned one. Our fuel cell systems can also be used for stationary applications, the very same fuel cell systems. For example, in backup power systems for data centers. As you might know, today, data centers do have backup power systems relying on diesel generators, which is probably not the way to go in the long run. So the companies offering such systems are now also looking at environmentally friendly solutions, and fuel cells could be one. That's what we work for with partners like the Rolls-Royce Power Systems company. And in the long run, fuel cells could even provide continuous power for such stationary applications if we drive up the lifetime of a fuel cell. We already did this on a prototype basis, also together with North American companies. There was a demonstration in Colorado in the US, for example, which we started in 2017, I think it was. So we are now at a level that we can offer our fuel cell systems for such applications as well. And there might be more in the future, like trains, maybe even small ships, boats, and maybe fuel cells could even play a role in airplanes in the future. But that's probably a much longer way to go.
Thank you for that. I think that's quite inspiring to see how far the technology has gone. One of the big challenges, of course, in the 90s was the cost of the fuel cells relative to competing technologies. And you said that there's been some dramatic advances in that. Do you see other opportunities there? What are the untapped opportunities in terms of innovation that are there to be cracked?
There's probably 2 points. One is we have to use less expensive materials in the fuel cell itself. And then there is, I would say, process engineering. So today, most fuel cells are, I would say, manufactured by a more or less handmade process like pick and place. And in the future, if we want to go to high volume, we have to invent automated processes to make fuel cells in order to drive the cost down. We have achieved a lot already, but we need to go further. One example is we could reduce the platinum content in the catalyst of the fuel cell by 90%. So we are now slightly above the platinum loading of an exhaust gas catalyst system. So we can go one step further, or we should go one step further also there in order to get to the same level as we are with internal combustion engines today.
It's remarkable when I think about the platinum intensity of the fuel cells of the 90s. And now a question that's come in from one of the chats was, has anyone at Mercedes-Benz been looking at the viability of synthetic carbon-based or carbon-neutral transportation fuels? So I guess this would be anthropogenic CO2 to transportation fuels and how that competes on a kind of full cycle cost basis with either hydrogen to fuel cells or battery electrics.
Yes, we have looked and we still look at such synthetic fuels, which we call power to liquid or power to gas. I think this is a good opportunity to make the existing vehicle fleets carbon neutral. It's very capital intensive, this technology, and there's one issue with that. Today, all regulations require that your vehicles are CO2 are zero emission vehicles on tank to wheel basis, so during vehicle operations. And unfortunately, these fuels don't offer this possibility. So they are only carbon neutral if you look at the whole cycle. So that's why we think this could help to reduce CO2 of the existing fleet. But for new vehicles, we would rather go with either battery or fuel cell technology. And cost calculations show that at sufficient volume and at hydrogen cost, which need to go down by 50% in comparison to today's levels, we can reach total cost of ownership parity with diesel on the fuel cell side. So this will probably happen in the early 2030s.
Great, and I see another question's come in. Would you be able to comment at all on the bottlenecks involved in creating fuel cell assembly plants? So actually the large-scale manufacture of fuel cells for deployment in fleets.
Actually, for the assembly, I don't see much bottlenecks. So the technology, at least in our regard, is known. You have to implement it. It's some investment needed. But I think the principles are all well understood. And actually, we are setting up plans to implement the biggest fuel cell plant in Europe. It will be a 10 gigawatt factory, so a real giga factory. And hopefully this will happen within the next 3 or 4 years in order to be ready for volume production in the 2026-7 timeframe.
Excellent, thank you. And would you be able to speak at all to the consortium that is building up green hydrogen supply? Is that an area where Mercedes is participating?
Yes, we do. We are part of the Green Deal of the European Union. So it's not our main business. Infrastructure is needed for our business, but we think we don't have all the know-how and competence to do this infrastructure business by ourselves. But we need to partner with competent other companies doing green hydrogen production, green hydrogen logistics, and eventually green hydrogen refueling infrastructure. So one example is Mercedes-Benz is a shareholder of a joint venture, H2 Mobility, in Germany. This joint venture is setting up infrastructure for hydrogen in Germany. We are only a small shareholder, but with this, we wanted to show we are supporting this, although it's not our core business.
Thank you for that. I guess in the couple minutes that we have left, I wonder if you could comment, based on your experience working with partners in Canada and elsewhere, what's the advice you would give to entrepreneurs from Canada in terms of how to work with your company and others like yours to participate in the tremendous transformation that's taking place in Germany and across the European Union in this space?
I think the first ingredient would be to have, I would say, some innovative spirit. Also, I think you need some stamina in order to survive in the fuel cell business, as you probably also know yourself. And then, other than that, we are quite flexible. And sometimes it's very difficult for small startup companies to work with big giant companies like Daimler, Mercedes, or Volvo. And that's why we think for new technologies, also on our side, it's good to have small entities like cellcentric. We are small, very small in comparison to Daimler. So we are, I would say, working on ice level with startup companies and young entrepreneurs, and especially our group in Canada. They are 50 very, very motivated people, knowing the Canadian background. So they are all Canadians. Besides, I think 2 Germans are working there. The rest is Canadians. So that's, I think, a good opportunity to team up, to get in contact and see whether there are business opportunities. Thanks for that, Christian.
Let me just see if there's a final question in the chat that we might have missed. But in the meantime, do you have any? Was there any question you would have liked to have been asked that you weren't asked?
I think most of it was covered. Maybe I saw one in the chat about what is the right fuel cell technology, talking about polymer electrolyte membrane technology. We are really firmly convinced this is the right technology. All other technologies don't fit to the automotive applications due to temperature, operating temperature. Doesn't make sense to have a device with operating on several hundred degrees centigrade on a vehicle. So we think PEM was and is the right choice for automotive. So the other question, which
go ahead.
I would have expected is, what's the right mean for technology for hydrogen storage on board a vehicle? This also depends on the application. We think for pass cars, high pressure hydrogen is the right solution. For long haul heavy duty, The optimum solution would be liquid, but as we discussed before, we need an agreement among all the parties involved. And the agreement is more important on the infrastructure side than the specific technology. We could do both, gaseous or liquid hydrogen, but we need this agreement in order to have uniform infrastructure and not a brand specific one.
I think that's a nice concluding comment for an effort to try and foster Canadian-European collaboration. Maybe we can work together to set some standards to enable the interoperability and growth of this sector broadly. Dr. Mohrdieck, thank you very much for joining us.
You're welcome.
And let me thank you. With that, let me ask you to turn your camera off, and I'll ask Beth to turn hers on. Welcome, Beth, and I will turn you over to our audience. Thank you.
Hi, Jason. Thank you so much for having me here today. I'm really happy to be able to talk about carbon capture, utilization, and storage. I think that it's becoming ever more a hot topic, especially as we start to talk about net zero and different commitments globally. So first of all, I want to thank the Clean Resource Innovation Network for allowing me to present today. I'm on their board, and I just want to talk a little bit about them initially, and then I'll go into the rest of my presentation. So just so you're aware, the Clean Resource Innovation Network, CRIN, it has just received a $100 million investment from the Government of Canada's Strategic Innovation Fund, and it's a good example of the committed investment in clean tech R&D for the oil and gas industry. You know, Canada's oil and gas industry is Canada's largest investor, and it has been, and StatsCan has shown this in clean technology and in growth in the industry's R&D investments, and continues to outpace other sectors. And so we know Canada is committed to being a global leader in clean technology development to address environmental and economic challenges in the oil and gas sector. And so CRIN is really unique because it's a network of networks, and it facilitates, you know, connections, collaborations, and an ideas sharing to create new partnerships that'll produce unexpected solutions for global challenges. You know, there obviously is no one solution, and I'll talk a bit about that today when I talk about CCS being one of the tools in the toolbox as a solution. But, you know, I want to just say that CRIN, its main role is not to be a funding organization, but they want to identify highest impact development projects and connect or direct those resources to accelerate the commercialization and widespread adoption. So CRIN actually announced last week 3 large-scale technology competitions with total funding awards of $80 million Canadian. International projects, of course, are eligible if certain criteria are met. And you can go to the cleanresourceinnovation.com website to see application details. They will include reducing environmental footprint, which is $50 million to address land, methane emissions, novel hydrocarbon extraction, and water challenges. And the second is $25 million for low emission fuels and products to develop value added lower carbon products and cleaner fuels. Which is interesting after hearing about the hydrogen fuel piece. And then $5 million for digital oil and gas. That would be addressing environmental monitoring, health and safety, and operational excellence and capital project execution. So I just wanted to give a shout out to CRIN before I started. And if you have any other questions, feel free to ask and go to the website. So I want to talk to you guys today about carbon capture and storage. So the International CCS Knowledge Center that I work at, we were founded 5 years ago after the Boundary Dam carbon capture and storage facility in Canada was established. So the Boundary Dam facility is the world's first large-scale post-combustion capture facility on a coal-fired power plant here in Canada. In fact, it's the only operating large-scale CCS plant on power in the world at this time. And one of the things that I think is important when this rebirth of CCS is starting to take hold is to understand how we got there and then what lessons can be shared and Canadian experience and expertise can be taken within Canada as we start to look at what CCS looks like moving forward and globally to the world. Because my new tagline that I've talked about is to get to net zero, we can't start from ground zero. I think that's really important, especially with technologies like carbon capture and storage, which have often faced a barrier of cost. So I'll start by saying, we know that Canada wants to reduce its emissions. Most countries, especially the ones signed on to the Paris Agreement, are committed to this. And before I go into the current status of CCS in Canada, I wanted to talk you through what the world is saying about CCS and its role in the mix of technologies required to meet climate targets. So coupled with many other clean technology solutions, as I mentioned, the large impact that CCS can have spans global mitigation outlooks. In fact, a sense of growing urgency for it is being felt. Fatih Birol, the head of the International Energy Agency, actually said that this is a rebirth of CCS. And their recent CCUS Clean Energy Transitions Report was released in September 2020. When they look at the sustainable development scenario with the Paris Agreement temperature goals, it shows that in just the next 10 years, global CCS deployment must increase by a factor of 20, focusing on first retrofitting existing power plants, kind of like what we did at Boundary Dam, and factories to capture over 800 million tons by 2030 alone. So we've got a lot of heavy lifting to get there. That's going to require large increases in investment in the near term to ensure deployment later in the decade. And then out to 2070, the IEA's same sustainable development scenario looks at 85% more CO2 being captured to result in over 10 billion tons of CO2 being captured, which is requiring 90% of it being stored and only 80% of it being used in other applications. And we can talk a little bit later about use in terms of permanent sequestration and the market opportunities for utilizing CO2 as well. In IEA's faster innovation case, they, getting to net zero by 2050, they actually say the world, of course, requires even more CCS in the energy mix. That it will include some bioenergy CCS, and direct air capture plays a big role here. Of course, Canada has fantastic carbon engineering out of BC that's proven direct air capture as well. So we're going to actually see over 8 billion tons that need to be captured through carbon capture and storage and bio CCS and DACs, direct air capture, that are going to be required to 2050 to get to net zero. And we're going to have to store 200 times more than the current levels. So I'm going to move on to talk a little bit about Canada, and because Canada really has been a leader in carbon capture and storage. Canada's record as a large-scale CCS leader, it dates back to the fall of 2000, when we actually had industrial-grade CO2 traveling across international borders, which is sometimes people don't necessarily know, by a 330-kilometer pipeline from North Dakota to Saskatchewan, right in the middle of Canada. And so in the United States, North Dakota's Great Plains Synfuels plant was actually capturing CO2 and storing it in the Saskatchewan Weyburn-Midale oil field using a process called enhanced oil recovery. And together, that project is basically, the field has stored almost 40 million tons of CO2 to date over those past 20 years. And there's an additional 2.8 million tons that's added annually to that reservoir. And so as a result, Saskatchewan is the home of the largest amount of injected anthropogenic CO2 in the world. Also, we're very familiar with the projects in Norway with Sleipner and Snøhvit and the fantastic work that was done there. And so there's a lot to be learned internationally as well. But just focusing on Canada a little bit more, I want to talk about some of the things that have been done here. So, but beyond the Weyburn project, Saskatchewan has, and its provincial utility, Sask Power, actually pioneered the way for the large-scale CCS facilities around the world with their fully integrated CCS project at Unit 3 of the Boundary Dam coal-fired power plant. And that's the project that the International CCS Knowledge Center has actually taken the engineers and the people that were instrumental in that development and taken that to specifically and solely share lessons learned based on large-scale deployment. We've applied those lessons learned to another coal plant just 12 kilometers down the road to see, applying lessons learned can have a 67% cost reduction with all things equal, and coal to coal, 12 kilometers away, and just economies of scale, doubling the size to 2 million tons instead of a 1 million ton reduction a year. So I think a 67% step change is fantastic for second generation. And that was done in a feasibility study, an engineering design study that happened 2 years ago. So those lessons learned are also being applied beyond that. And the International CCS Knowledge Center has, worked with the UK, Norway, different projects in the United States, China, you name it, to try and share Canadian lessons learned. But currently we're also conducting a feasibility study beyond coal to cement. And I think it's important to look at industrial process emissions, especially ones like cement, that don't have the opportunity to fuel switch or have other options to reduce emissions. Process emissions from cement are 2/3 of the emissions, and the only way to reduce them significantly is to target large-scale carbon capture and storage. And so with cement being about 8% of global emissions, and having many similarities to coal, actually, large-scale post-combustion capture is a very viable way to approach reducing emissions now with a technology readiness level of 9 or that has already been proven and deployed. So I think it's something that's really important, and I'm happy to talk about that later. So I also want to talk about Alberta, because Alberta has also been a leader in capturing and storing CO2. The Quest CCS facility near Edmonton, Alberta operates what's called a blue hydrogen facility at the Scotford Upgrader. Capturing and storing 1/3 of the CO2 emissions from a steam methane reformer process for hydrogen production. The facility uses hydrogen to turn oil sands bitumen into synthetic crude that can be refined into fuel and other products. In the 5 years since its startup, it's actually captured and safely stored 5 million tons of CO2. It's the most of any onshore CCS facility has stored globally, and it proves that large-scale CO2 capture is safe and effective to reduce CO2 emissions from industrial sources. And so, Quest and Boundary Dam kind of were trucking along as those two foundational pioneer projects in Canada. And recently, last year, we actually saw, or June 2020, we actually saw the Alberta Carbon Trunk Line System launch. And it's a perfect example of a carbon capture and storage hub. And you're seeing this come out of places like the UK right now, where they're looking at clusters of activity. We'll talk a little bit about that in a second. But the ACTL is a great example of build it and they will come approach. They have a 14.6 million ton CO2 capacity pipeline, currently just putting 2 projects into it. But it's able to then be accessed by others. So if you overbuild, you actually are able to have more access by people. So start with an anchor, start with a lower cost capture, like a refinery or a fertilizer facility, and get in there. And then the harder to abate sectors can then start to join on in time, and they don't have to worry as much about the costs of the full chain of CCS. And so, ACTL was fantastic because it was designed as this backbone infrastructure that needed to support this low carbon economy. And it currently is capturing, like I said, from 2 blue hydrogen anchor projects, the Sturgeon Refinery, owned by the Northwest Redwater Partnership, and Nutrien's Redwater Fertilizer Facility. And then the CO2 is used by Enhance Energy for enhanced oil recovery in the Clive oil field. So it's a really fantastic example, like I mentioned. And the Canadian Pension Plan actually backed this, because investments and carbon prices are looking to be something that are really going to help to drive. So I just want to talk a little bit about iterations and shared infrastructure bringing down costs. So with new technologies, there's always room to optimize and improve the development processes. Many of the common hurdles for large-scale CCS can be addressed when projects share knowledge and don't start from ground zero, like I mentioned, in their development. I just have a question for Jason really quickly. It says in the chat that there's only 2 minutes left, but I thought we were going till 12:45, just to clarify, because I will stop if you need me to, but I'm going to keep going.
Yeah, no, Beth, we just wanted to leave time for some Q&A, but please carry on.
Yeah, okay, just because it said 2 minutes left in the chat, and I thought it was till 12:45, so I just want to make sure.
No, we've still got plenty of time.
Okay, great, thanks. Sorry about that. So just to talk about next generation CCS technology, we're hoping, through iterations, it'll be significantly cheaper, more efficient, and will integrate well with renewable energy and other sectors. Shell has even stated that if Quest had been done again, it would cost about 30% less, thanks to capital efficiency improvements. And so drawing on the hands-on deployment experience from Boundary Dam, from Quest, et cetera, those are the types of things that Canada can really offer the world in sharing those lessons learned and bringing them, to Canada as well. I also want to just briefly talk about, economic stimulus. And so when we look at the math, just 3 large CCS projects could reduce about 5 million tons of CO2, which is about 6,000 construction jobs, with a $2.7 billion GDP in direct, indirect, and induced jobs. This is fantastic numbers. It includes highly skilled trades, and so those clean jobs are going to be very important. At the Boundary Dam project, there were 5 million man hours of construction with 60 contracted companies and 1,700 contractors and SaskPower employees that were there. So what's going to get us there next? And that's what we can talk about a little bit in the questions with Jason. But basically, what I want to say is that, recently Alberta has asked Canada for a $30 billion commitment for new CCS, so the next wave of CCS projects. I think the most important thing is that we don't start everything from scratch, but maybe we can talk a little bit about the role of SMEs and how new people trying to get into this market are going to be a part of that, because I think that, wanting to get to targets by 2030, 2050, there's a lot of large scale deployment and large emission reductions that need to take place now. And so while I think it's really important to always have R&D, that deployment piece is now kind of the weighted balance that we're seeing. So I'll leave it there, Jason, and we can get to some questions.
Awesome, thank you. Well, fantastic overview, and thank you for the shout out for the Clean Resource Innovation Network. In the spirit of full disclosure, I'm a vice chair of that initiative to drive up the clock speed of innovation in Canada's oil and gas sector. And of course, any opportunity to bring the world's innovators into that discussion is very welcome. Beth, you set the table for us, but similar to fuel cells, I think we saw a previous wave of enthusiasm for CCS technology in the early 2000s that foundered in the reality of the cost of large project deployment. What's different this time in your experience or expectation?
Yeah, it's a really great question. I think urgency is one of those things. I think that CCS has been shown as proven. And what happened, I think, is that the first projects get funded, by the government, and they're there, those demonstration projects get funded. But the second projects, you wait for industry to come in and take on that role. And there's a hurdle there when it came to CCS, because the Boundary Dam project was $1.5 billion. And so that's expensive for industry to get behind, especially when a price on carbon wasn't well established to have you need to avoid paying a carbon tax or having a value for those credits that you're sequestering. And so that hurdle ended up having Canada focus a lot of its attention on the R&D piece. And what else can we do to drive the market value of CO2? How can we make carbon nanotubes and put CO2 in cement and all of these fantastic things that create a value proposition for CO2? And while those things are all going to be super important, I think, that's where a lot of the money is going to be derived in the marketplace. The piece about that I mentioned at the beginning about the IEA saying only 8% is going to make up what we need to permanently store to get to these targets in these utilization ways. So that giant other percent, is where we're seeing the sequestration and EOR for those large scale, 500,000, 1 million ton, 2 million ton capture projects. And, Jason, I always say, I love a good beer at the end of the day, but, you can't drink that much beer, with that much CO2. You're not going to use that much, So that I think that's where the change has been. And in the United States as well, we saw an incentive called 45Q. And in fact, the International CCS Knowledge Center helped the Senate staffers with the development of that incentive bill. And it actually looks to have incentives for permanently sequestering CO2. So it's $35 a ton for enhanced oil recovery and $50 a ton for other permanent sequestration. And I think that with that, you saw about 27 to 30 CCS projects that accelerated themselves. And so for places like Norway, for the UK, for even Australia, and obviously Canada, everybody had dabbled in the CCS space, and they didn't want to be a laggard compared to the United States, to be honest. And so with that experience that they had, they just wanted to go for it. And so what does that look like for Canada in terms of incentives? It's easy to say we want what they have, but when you look at it, Canada's tax system isn't structured in that same way. So what is most beneficial for Canadians and those projects? In Norway, when we see the Northern Lights project going forward and Project Longship, 80% of that is government funded. Is that what Canada wants? So each place is going to have different incentives to try and get these projects up and running. And I think an incentive project for Canada would suit well. I would worry that there would be a delay that was created like in the United States when there was certainty being looked for by companies. So that gap period, actually, we want to avoid that. So I think that would be my word of wisdom advice, to make sure there's no delay in projects that you're trying to incent short time frame. Yeah.
So there's a lot to unpack there. One of your comments was related to carbon utilization, and really just the kind of small absorptive capacity of that market, really relative to the 10 billion tons a year that you mentioned earlier in your presentation. What do you see as the real technology development opportunities for innovators? Where's the opportunity beyond, you mentioned integration with renewables. What are some of the other areas you think are most promising? And I apologize, I appear to be having some bandwidth issues on my side.
No, it's not a problem. So yeah, it's a great question. So I still think that there's a great market and dollar value for the utilization of CO2. And I think that's something that there's lots of room in this space for. I think it's a different conversation. I think that one thing that we have to be very cognizant of is a company that wants to capture, 1 million tons a year. My advice to them would probably be to have one contract for the CO2 and the storage of it. So it's hard to take a flange and take off some of the smaller amount to provide it to those smaller utilization pieces. So I think that maybe a government program to incent that would also be a really wise idea if the government is looking to also capitalize on the market of products for CO2 utilization. But again, that large piece is important. So that's a little bit of a hurdle. I don't think that we can't surmount it, because the value of those products is quite good. So while it might be $170 a ton, by 2030 for sequestering it in the ground permanently, potentially, those carbon nanotubes are going to be worth a lot more. So that balance of what that end use of the CO2 and the amount of CO2 that you're looking at is going to be something to take into consideration, certainly. I think also for people that want to get in this game, I mean, you hear $30 billion that it's going to go to CCS. It sounds great, right? You're like, I want to get in on that. I want to just, put a little bit of a cautionary tale on that and say, when the Boundary Dam project started happening, it was 10 years before that CCS was started to look at. You have to have these feasibility studies. You have to have front-end engineering design studies. It takes, years to get to a place that you're having a shovel in the ground. And when the Boundary Dam project was going forward, it actually was the only one out of 10 other projects that ended up moving forward. So, it's exciting. There's a pull from governments and pull from, people to want this, but it has to be done correctly in order to keep costs down. So if you're looking into the side of making a new technology, there's a lot of work to go in there, right? People like Mitsubishi Heavy Industries that have a solvent for post-combustion capture, they've spent decades refining that to get to where they are. So, and pilots and testing and things like that. And so it's a hard circle, square to circle, circle to square, whatever the metaphor is, because, you see an opportunity that you want to be a part of. If you're not TR9, are you going to be a part of that $30 billion place? And I would say there is still roles for things like modularization, trying to figure out those pieces. What's really important to know is that CCS is not something you can just go buy off the shelf. And so it's not a box that you fit on a plant. And it's tailored and it's integrated and it's unique to whatever your flue gas content is. And things that have more particulates in their emissions, more pollutants, the particulate matters, SOx and NOx, et cetera, those things are going to be harder to get to the CO2. It's going to be harder to access the CO2 to capture it. And while it's great that something like a coal plant is actually, we get rid of 100% of the SO2, which is acid rain at the Boundary Dam facility in order to get to the CO2. But that process is complex. And so generic amines and things like that, you're going to see over time that it might have worked in a small pilot test, for Monday to Friday, 8 to 5. But as soon as you're running 24/7 on holidays and for 3,000 hours, after that time at large amounts, you start to see things go weird and funny. And that's some of those lessons learned that Canada can offer as well.
Well, we have a question in the chat, specifically, what's your advice for entrepreneurs? I assume this is from Europe in particular, who are looking to access opportunities in the Canadian market.
Sure. In the CCS space, for sure, it depends on what part of the space you're looking at, right? Like I said, there's different components. So there's the capture and the technology to capture, and then how much is going to be captured. So if you have a brand new technology, there's lots of testing opportunities in Canada. There's a test facility in Alberta. There's one in southern Saskatchewan where you can actually test your products. Maybe you can partner with an oil and gas company or something to try and start to test that out. People that are willing to take that time, you have to find the people that aren't needing to urgently reduce today. So if that's your space, I would recommend that type of an approach. And of course, CRIN is a fantastic place to start because, that's a network of networks and you can really try and capitalize on tapping into people there. If your space is more of a utilization space, there's always people that are looking to try and figure out how to get rid of their CO2, right? So if you can capture small amounts, maybe that gets you part of the way there. It's hard to answer the question, what advice would I have for entrepreneurs wanting to get in the space? Because it depends on what part of the space you want to get into, right? Jason, is it going to be, do you want to get into the pipelines? Do you want to store? Are you going to, apply to the Alberta government to have pore space and permitting to store? So maybe there's room and opportunities for measuring and monitoring and, health and safety programs. All of those things are definitely going to be becoming more important.
Thank you for that. Well, in 3 moments that we have left, I guess, you know, there are some specific things around the Canadian experience that might be relevant for our international stakeholders. For example, securing social license for large-scale CCS projects. What do you think is some of the advice that we as Canadians can offer to our European colleagues in terms of how to create an effective and viable market for CCS?
A great question. You know, we're very fortunate in Canada that the places that we have large scale sequestration opportunities, particularly Saskatchewan and Alberta, you know, have decades of understanding of the subsurface. You know, so monitoring every which way from Sunday is very important. I think what's really something that Canada can offer is the robust long-term liability process, especially that Alberta has designed, to show that, oh, you know, the company that's sequestering, whether it be for enhanced oil recovery or permanent sequestration, takes on that that role of liability. But after time, you know, if that company dissolves, et cetera, it actually goes back to the government. There's also a post-closure stewardship fund that payments have to be made into. So there's a lot of long-term liability pieces that those regulatory pieces can actually provide confidence to the public for understanding that this is secure and safe. Projects like the Weyburn Enhanced Oil Recovery Project. I know that Europe is not a big fan of enhanced oil recovery, and that's fine, but the sequestration aspect of it, you know, to have over 40 million tons sequestered over 2 decades is things we can turn to say, this is proven, this is done, and it's safe. And so when you have the right people involved, you have robust monitoring, especially when you have oil and gas companies involved in the sequestration piece. That's their business. They've understood this from years, and they are experts.
Thank you. And I guess, you know, last word, Beth, is there any question I didn't ask you that you wish I had?
You know, I think that the question would be, you know, is this going to happen? You know, it's a funny question, but I think that my biggest fear, Jason, is that everyone thinks that they can go out and buy this technology off the shelf, buy a hat, you know, an accessory, and put it on. You know, engineers within companies think that they can do this, and we've seen this before. We saw this 10 years ago. So my biggest fear is that everyone's going to think that they can do it on their own, and I know that there's a lot of information out there that can help people and act as a tour guide, not just a research paper to read, for understanding how your project can be more effective, less time consuming, and, you know, not be a big pain in the bank, to be frank. So
thank you.
Yeah.
Well, look, it's been a terrific discussion, 2 fantastic panelists, a lot of insight into both the European and Canadian markets and experiences in fuel cell technology and in CCUS. I want to thank both panelists, Beth Valiaho and Dr. Christian Mohrdieck. Thank you both for joining us. Thank you all for being part of this. And I turn you back to your agenda now. Thank you again.
You're welcome.